Okay, so one of the questions I had was about this problem right here, and it's why isn't the area equal to 0? Because if we go over to Desmos, um, the graph in blue, that's like the graph that we're looking at, and then 1 and 7 are our bounds. X equals 4, this is where our asymptote is, right? And when we solve this problem, we want to break it up around the asymptote. So this left side of 4, on the left side of this black line, because the graph is symmetrical, the question is like, why isn't the area, again, like integrals area under the curve, why isn't this negative area plus this positive area just all cancels out and equals to 0? And this has to do with the idea of like infinity and like this concept of infinity. After doing these like, finding these like individual pieces, you'll find that this left equation, the the answer to this would be negative infinity, and that's shown by like this. This is underneath the x-axis over here, and it's going down all the way to infinity. But the answer to this is negative infinity. The answer to this is positive infinity. So then negative infinity plus positive infinity, why is that not equal to 0? And this, there's actually more of like for now we wouldn't we for now let's go back to L'Hopital's rule and then to this idea of indeterminate forms, meaning it cannot be determined. So here we see that infinity minus infinity, this is indeed one of our like indeterminate forms that we see in this improper integrals, um, because this evaluates to negative infinity plus positive infinity. We can't determine that. You can't cancel infinity out to just to be 0. Like, from the looks of it, this graph, like I see the confusion. Like this is a symmetrical graph, so like why wouldn't the area just cancel out? But we actually like it just can't be determined because of the idea of just infinity in general. And like people do studies on this all the time, and there's like a deeper study in math, going back to like number theory and like just there's studies done for infinity, but for now in Calc BC, um, we don't need to worry about that. But I hope this explains why negative infinity plus infinity for this question isn't 0, and in fact this question actually diverges, and this is shown by like just putting in decimal right here. When I put this on Desmos, you'll see that it's undefined.